Alright, welcome back. So in the previous page, we have shown you the architecture for processing queries in database systems. And we also mentioned some terms in the architecture, right? The query execution plan, as well as record index requests, page commands, and read-write pages, right? We will introduce some of these terms later in the slides. And before we move to the query execution plans, we need to introduce another terminology first. It is called the logical versus the physical operators. If you still remember, right, in the relational algebra, we have introduced what are the logical operators in database system or in the relational algebra. So formally, the logical operators that describe what we want to do or what we plan to do. They are most focused on the logical design of the operators. It describes what we plan to do with these operators. And we show some example in this page, right? For the logical operators we have mentioned before or introduced before, the first operator we can use is the union between two relations, right? So given two relations, we can union them together and generate a new relation instead. And this new relation will cover the union of the items as well as the records in the two inputs relations, right? Besides the union, we also have some other operators like the selection, right? Given the relation, we can select some of the rows, right? Or some of the records matching our requirements or conditions. It is called selection. And we also have the projection. Projection is to project some columns of the attributes of the relation instead, right? Now, given a relation with lots of attributes, we only require a few number of the relation, a few number of attributes instead. Then we can use this projection to select some of the columns instead. And we also have a join. Join denotes the combination of multiple relations, right? Based on some common attributes or based on some conditions. So we have also introduced joins before, right? If you still remember. Besides join, we also have the grouping, right? Grouping by, right? It is based on some provided attributes, and we can group the data in the database systems according to some provided attributes instead. And in this way, we can do many interesting queries based on these groups, right? So these are the operators we have introduced before in the relational algebra as well as SQL, and I hope you still remember them. So formally, these operators that describe what we want to do or what we plan to do with these operators. Another new term we plan to introduce here is called the physical operators. Physical operator that denotes the concrete operator which will deal with the database systems. Generally, in other words, it's a physical operator that focuses more on how to do the operators. In other words, it's the physical operators that try to implement the function of these logical operators. Now, before we have the union, we have selection, we have projection. However, we never describe how to do these kinds of operators based on the real-world database system with some program, right? So then we need to use the physical operators to help us to define or describe how we implement the logical operators. So we will mention some of the physical operators in this section, like the nested loop join, the submerged join, hash join, and index join. And we will introduce them in detailed information in the following pages instead. So you can know the difference between the logical versus the physical operators. Logical operator is more focused on describe what we want to do. However, physical operator is more focused on describe how we want to do these kinds of operations. Okay, so this is two terms we plan to describe before we move to the new page. Okay, so in the previous page, we have mentioned two terms for you already for both logical and physical operators. And then when we introduce another term we mentioned in the architecture for query processing, it is called query execution plan. What does this mean? So in the page, we show you with the example to illustrate what is a query execution plan for some input queries. Let's assume we have one query input. It is called select p.buyer from purchase p. In other words, we provide a new name for a purchase table, right? This relation. We name it as p. As well as person q. We have to provide new name for the person table in this relation, right, as a queue. And we have some condition where p.buyer equals to q.name, and also q.city equals to nc, and the phone number of q is larger than 543 and 0000. In other words, this query plan to find some buyers, the name, and also the buyer have some buyer or this transaction records, and the address of the buyer is in Tallahassee, and also we have some requirements for the phone numbers of the buyer, right? The query seems to be very easy and very straightforward and also easy to follow, right? And you can understand what is this query plan to do. Then, how can we process these queries? According to the query processing architecture we showed before, given the query inputs, we have to use this query compiler to generate some machine language, right, based on query inputs, and then we have to design the query execution plan for it. Then the question will be, what is the query execution plan? In this page, we show you with example. So forming the query execution plan covers many different information. First of all, you need to cover the logical tree for processing the queries. So given the query inputs, we need to design a query tree or logic tree of the query. And also need to decide the implementation choice at every node inside this tree, and also scheduling of the operations inside the tree. So what does this mean? So given the query inputs, we can design its logical tree for processing it, as shown on the right hand side. Because this query is operating based on two relations, the purchase table, the person table, right? In other words, given these two tables or these two relations, and we can give them as inputs into the logical tree. And between them, we have to join them together, right? And the join operation is according to the condition we provide here. The p.buyer equals to q.name. In other words, according to the buyer name, we can join these two relations or these two tables together, right, in the logical tree. And we can use some simple nested loops to define the joins. We will show later what does this mean. And given these two joins of these two tables, and we can first do the selection, right? With selection according to some conditions. First of all, the city of the buyer should be Tanahashi, and also the phone number of the buyer should be 5430000, right? And according to the condition, we can do some selections. Also, according to the query, we are selecting the p.buyer, right? In other words, we have to project the buyer name as the final result, and therefore we have one projection at the top, projection of the buyer attribute of this relation, right? So this actually defines the logic operators based on the table inputs, and with this operators we can be able to generate the final results for the query. So, some operators are from the relational algebra and some others are not. For example, given the two tables, we have to scan them, right? As well, we have to scan the index table as well. So these two operators, they are from the physical operators actually. As well as simple nested loops, they are also the physical operators. And some other operators like join, selection, projection, they are from the relational operator and relational algebra instead. Okay, so this is how to design the query execution plan based on query inputs. It is based on the logical tree, as well as design of the implementation plans and choices at every node inside this tree.